Let's go. Okay, so let's take a look at this one then. So we talked a little bit about this one. We started talking about this one on Monday. This is, I realize that this one, is a little tough. It's got some quadratic expressions in it, but you don't have the option of just not doing these. We're going to do these all year. They'll get easier all year long as we go through them. But I want you to be able to deal with situations like this. It's important to be able to do going into Algebra 2. So, what can we do here? What's the picture that we draw in this case? So we've got point S is between points R and T. So what do you think? What's a line? Good. And maybe not a line, but a line. How about a line segment? Okay, so a line segment, very good. And what points would I label on this segment?
R, S, and T.
Okay, so we're going to have the endpoints are going to be R and T, and then someplace in between, I've got the point S. Now, this might seem like kind of a minor point. I can't remember talking about this or not. I probably did, but just in case I didn't. Why would it maybe not be a good idea for me when I'm drawing this picture to put the S where it looks like it's in the middle? It's probably not in the middle, and I might confuse myself. If I put the S in where it looks like it's in the middle, I might be tempted to think, okay, it's a midpoint, and so that gives me some extra things I can do, right? Some extra equations I can set up. But we're not told that, so we can't assume that, right? So I'm going to put it someplace where it's obviously not the midpoint. So then what's the geometry relationship that we get from this? What do we know about the segments up there? What do you think? What do you think? Serene, what do we know?
RS plus ST equals RT.
Okay, good. So we know that this short distance right there that we call RS plus this short distance that we're calling ST must equal the length of the whole thing, the long distance RT, right? So there's the equation we get up from the geometry perspective. We're given expressions for each of those distances or segment lengths. So we can substitute, right? So instead of RS, we're going to plug in 2x squared minus 232, right? Plus, instead of ST, we're going to plug in x squared minus x minus 125. And on the other side, instead of RT, we're going to plug in this expression. So 4x squared plus 4x minus 423. Now that looks like a mess, I agree. That looks like a mess. But it's really not that bad, right? It's really not that big a deal. We just have to start from the beginning and work through the algebra. We can shift into algebra mode here, right? So this isn't as confusing. Let me just grab this whole expression, and we'll go to a new page so it looks neater. Okay. So talk to me about that. What are we going to do? Combine like terms, sure. It looks like, here's our equal sign, right? So on the right side, we don't really need to combine any like terms. On the right side, everything's already simplified. But on the left side, I can combine like terms. So how about x squareds? How many x squareds am I going to get? Okay, I'm going to combine the 2x squared plus x squared and get 3x squared. How many x terms do we have? Looks like just one. So I've got a minus x. We took care of that one. And then numbers. We've got two numbers to combine, negative 232 plus negative 125. What did we say that was? What, negative 357 for those two. And then on this side, we've just got our 4x squared plus 4x minus 423. Okay, good. So we simplified each side. Now here's where things get maybe a little bit different than what we've done on the easier problems. When we've got quadratic expressions like this, where we've got x squareds and x's and numbers, what do we do? Remember? Say it again. We gotta move it to one side. We gotta get everything on one side and 0 on the other. Very good. Now we have to be a little bit careful about this though. This is important. We wanna make sure that we have a positive number of x squareds always, right? And we'll do that this year, next year, forever. We'll always wanna do that. So which side are we gonna move everything over to then? To the right side, because 4x squared is bigger than 3x squared, right? So to do that, how do I undo all of these things? First, I'm going to subtract 3x squared from both sides. What about this one? Good. Add x. And how do I undo this one? Add 357. And if I do all that stuff, as advertised, all this stuff goes away. And so what's left on the left side? 0. Okay, on the right side, let's combine terms. What's positive 4x squared minus 3x squared? Good, just 1x squared, or we'd write it just as x squared, right? 4x plus x, 5x. Negative 423 plus 357, you're welcome to use calculators on this. Okay, negative 66, good. So now, our goal here is we've got to find the values of x that are going to make that expression on the right equal 0. Later on, I'm going to give you some other tricks for that, but for now, we only have one method for doing this. Factoring the right side and setting the factors equal to 0, right? But I'm always going to give you ones that factor easily. Okay, so this is an easy factoring problem, no bottoms up here, because we have a 1 in front of the x squared, right? So remember how we dealt with this. We said when we're factoring the easy kind, before I do anything, I'm just going to write down the template. So I know the answer is going to look like that, right? What else do I know about this before I do anything? What are the first terms? X is good. So I get an x there and an x there. And now my magic numbers. We haven't done this in a little while. What are the numbers having to do? I have to find numbers that multiply to negative 66 and add to 5. Okay, so roll this up a little bit. So we have to multiply to negative 66, add to positive 5. So what are those numbers going to be? Multiply, and you might have to think about what the factors of negative 66 are. There aren't very many, are there? There's not a ton. Any ideas?
11 and negative 6.
Okay, 11 and negative 6 would be the ones, wouldn't they? Positive 11 and negative 6, add to positive 5, multiply to negative 66, right? So then we know that those are the numbers that go there and there, right? Okay, so those aren't the answers though. This is a common mistake people make, is they think those are the x values I'm going to plug back in, and they're not. We haven't finished yet, right? Because what I'm really looking for are the values of x that are going to make these factors equal to 0, right? Because I've got this factor times this factor has to equal 0. What's the only way to multiply numbers and get 0? Multiply by 0. It's the only way to do it. There's no other way to multiply and get 0. I must multiply by 0 to get 0. So I've got two possibilities, and I think this is maybe, to me, this is how I always think about it. We can set up equations, but I just ask myself the question, what's the value of x that's going to make that factor equal to 0? What plus 11 is 0? Negative 11. So one possible answer is x equals negative 11. Or, how about there? What's going to be the value of x that makes that factor 0? What minus 6 is 0? 6. Yeah. So those are the two, algebraically, those are the two answers, right? So now I've just got to go back and test those out and see which one of those works in the geometry situation. Now we're done with the algebra. Those are my algebra solutions. So let's go back. So now we've got to try them out here. same problem. So let's try out, how about, what were they again? We had 6 and negative 11, is that right?
Negative 16. Oh, yeah. That's it.
Okay, so we got, I think, so we ended up with, whoops, we ended up with, all the algebra told us that either x equals 6 or x equals negative 11, right? After we solve set the factors equal to 0 and solve. So let's try 6. We'll just see if it works. If it works, we're done. If I plug 6 in down here, what's going to happen? So for RS, that's going to give me 2 times 6 squared minus 232. Do you see a problem with that?
Negative.
It's going to be negative. I don't even have to, I could put it in a calculator, but I don't even have to. What's 6 squared? 36 times 2. Wouldn't you agree that that positive number is going to be smaller than this negative number? Right? And so already I know I'm just going to get some negative number, and that's can't work, right? We can't have a negative segment length. So we know, what do we know about the 6? That one didn't work, right? We can just cross that one out. X equals 6, even though it worked for the algebra, it doesn't work for the geometry. So we'll go try this one instead. Okay, so we'll try x equals negative 11, see what we get. So RS then is going to equal 2 times negative 11 squared minus 232. Now, talk to me about how I'm going to do this on a calculator. How do I square negative 11? Okay, I mean, I could just say negative 11 times negative 11, or I could do negative 11 squared. But if I input negative 11, what do I have to do? Have to have parentheses, right? Or I'm going to get it wrong. What's maybe even a better way to deal with this? Whenever we square a negative number, what can we always do instead? Yeah, just square the positive, right? So just even forget about the fact that that's a negative 11. Just make it positive, right? Because they're both going to be the same answer anyway. So what do we get here? What is 11 squared? 121. So 2 times 121 is what, 242? Minus 232 is what? 10. Yeah. So there's my first answer. Right? What about ST? What do we get there? Well, that's going to give us negative 11 squared, make it positive, minus negative 11. Now that one I can't just change, right, because it's not being squared. Minus 125. Well, 11 squared, you already told me, is 121. Minus negative 11 is the same as what? Plus 11. Minus 125. So what's that going to give us? 132 minus 125 is what? What do you think? 7. Good. Okay, so what should RT be then? 17, sure. We know that's, if I did this correctly, that's got to be the answer. How could I check if I'm doing this on a test? Plug it in. Sure, I could actually plug in negative 11 for x, and this better give me 17. If it doesn't, what's that mean? Maybe I made a mistake, and I might want to go back and try this one again, right? Okay, questions? Make sense? Okay. Okay, last one. This guy. This is, I don't know, I mean, I don't know if this is harder or easier. I don't think the math is quite as hard, but there's maybe a little more to do here, honestly. What do we notice about this? So they give me the measures of these 3 angles. What do you notice about this that maybe makes this a little more complicated? And they all have x's and y's. Good. Remember our rule. The fundamental rule of algebra tells us that if I have 2 unknowns and I want to solve for both of those, how many equations must I have? Got to have at least 2, don't I? So somehow I've got to come up with 2 geometry relationships that I can turn into 2 algebra equations, right? So I'm gonna go ahead and write these, I'm gonna add these to our picture. So let's see, we had the measure of angle ABP, that's this upper right one, is 5x plus 4y minus 91. PBS is the upper left, that's 2x plus 6y minus 141. And SBJ is the bottom left, that's 3x plus 4y minus 59. So what's one geometry relationship there that we could take advantage of? What do you think? What's a geometry relationship we could take advantage of? Savannah, you have any ideas? I have two lines crossing like that.
I don't know what it's called.
Well, that's okay, just describe it to me. I don't care if you
SBJ and ABP or something.
Yeah, they're the same. So those two are the same, aren't they? Right? Who can remember what we call that? Yeah, vertical angles. Yeah, but more importantly is the relationship. That's just a vocabulary word, right? So we know that those two are congruent, so their measures are equal. So that's good. That's going to allow me to set up an equation, isn't it? So from that relationship, we get 5x plus 4y minus 91 is equal to 3x plus 4y minus 59, right? Okay, what do we want to do to this? Now, this is, you got to kind of think back a little bit here. When we're setting up equations to solve for both x and y. We can write them in any form, but if you think back to when we did our algebra review at the beginning of the year, remember that it was easiest for us to deal with these when we wrote the equations in the form some number times x plus some number times y equals a number. And we call that standard form for a linear equation, not for quadratic, but for a linear equation. And so we want to get the x and y terms on the left maybe and the numbers on the right. Okay, so what does that mean we want to do then? If I want to get the x and y terms on the left and the numbers on the right, how am I going to deal with that algebraically? What do I need to do to both sides to accomplish that? Suggestion. I've already got an x term over there, but I've got this guy here that's on the right side. Yeah, I got to get him to the left, so I got to subtract 3x from both sides. Okay, that's good. That's going to get rid of the x's from that side. Now I'm going to end up with them on this side. How many x's am I going to end up with? 2. Good. 2x. What about the y's?
Minus 4y.
Okay, subtract 4y. Good, and that worked out great because the y's go away completely, which actually helps, right? Then I'm going to have no y's in this equation. And then I want the numbers on the other side, right? So what do? Add 91. And those go away, and let's see, negative 59 plus 91, so that's what, 32? Okay. Whoops. So we get the equation 2x equals 32. Okay, that's good. That's one of the equations that we need. And we need a second one though. So we need another geometry relationship. What's another equation we can do? Get an idea? Cassie, get an idea. What do you think?
2x is the top two.
Okay, the top two.
You know, 180.
Yeah. Okay, good. The sum of their measures is 180. Good. What do we call that relationship? Linear pair. Yeah, we know that if we have a linear pair, so the non-shared sides make a line, then we know that they're supplementary, so their angles add to 180. Good. All right, so let's make that equation. Boy, this is going to run out of space here. Let me do this. About Okay, so we get then the equation 2x plus 6y minus 141 plus 5x plus 4y minus 91 all equals 180. So what do I do to simplify that? What do you think? Shaw, what am I going to do there?
Combine like terms.
Combine like terms, very good. So 2x plus 5x gives me 7x. So those guys are gone. 6y plus 4y, 10y. So those are combined. Negative 141 and negative 91 is negative 232. So they're combined, and it equals 180. What's probably the last step there? What do you think? Alec, what do you think the last step is? Well, remember how we wanted this? We wanted, when we're solving this system, we want to get the x's and the y's on the left and the numbers on the right. So I got a number on the left, I got to get rid of it.
So add.
Yeah, so add 232, good, to both sides. Okay, and if we do that, we end up with 7x plus 10y equals, what is that? 412, yeah, that's right, okay, good. 412. So now we've got two equations. So let's take those two equations and let's solve the system. So here was one, 2x equals 32. And there's the other one, 7x plus 10y equals 412. Now we lucked out. We don't have x's and y's in the top one, but if we did, remember how we deal with those, right? A lot of times we'll multiply both equations by something so we can get either the x's or the y's to cancel, right? Or we could solve for a variable, we could isolate a variable in one of the equations and substitute. That's what we're going to do here, isn't it? Right? What can I do with this top equation? If I solve for x, what do I get? Yep. Oh, question. Oh, you have an answer? Okay.
No, I don't.
But you have a question?
No, I don't have a question yet.
Okay.
Never mind.
Okay. So what do I get there if I solve for x? 16. Good. So I get the answer x equals 16. So there's my substitution, right? I know the value of that variable. Plug it into the other one, right? We're halfway there. If I plug in 16 for x, what do I get? 7 times 16 plus 10 times y equals 412. What is that? 112? 7 times 16, 112 plus 10y equals 412. So what do I have to do to solve for y? Subtract 112. Good. And I get 10y equals, what's 412 minus 112? 300. Okay, now what? Divide by 10. And so I can just cancel the 0, can't I? So what do I get? Y equals 30. We already know that x equals 16, right? And so all I have to do then is what? If I go back to the original problem. See, this was 16? And that was 30. And how would I find the measure of angle PBS? Plug them in, right? Plug them in right there. Okay, make sense? Okay? All right. We're good. Let's go to, I think, 205.